Hello guys, today these people presented very good projects and we're going to ask them about how the project, like how they came about with it. They're going to tell us specifically so that I will not be a second party narrator teller. You understand? So ladies and gentlemen, I'm going to start with my right. Can you tell us a bit about yourself?
My name is Abdul Sise, bachelor degree in computer science. Work on automotive and embedded system.
Okay, can you tell us about yourself?
Yeah, my name is Usman Jasi. I have a background in mathematics, physics, self-taught computer programming, and electronics.
So the thing is, he studied computer science and this person studied maths and physics, but they came together to achieve a project. And what is the project about? We are going to find out right now. Can you tell us about your project?
So the project that we are solving is smart irrigation system.
Okay.
Where we will be, solving problems based on smart irrigation system.
Okay.
To eliminate the primitive farming that we know. Yeah.
Okay. So like you are able to apply physics in this project?
Yeah, of course, yeah. Because reason why I can able to do well in embedded system, which is electronics with the firmware, is because of what I know previously in physics. And the mathematics also helped me to understand how to talk to the hardware directly by using the physical the registers and also the firmware, which is mathematics algorithm based.
If lines of codes and system on chips integrated in our phone can enable us to see our brothers in the diaspora through video calls, I guess if the same thing is integrated into the hardwares, it can also enable us to perform agriculture remotely. This is what we call remote farming. You can be at the comfort of your office, operating hectares of land, populated with tens of thousands of plants, with zero intervention, zero footprint. You can do your work as stated by your boss and yet having another source of income somewhere out there. This is what we call tech-driven agriculture. And we are here to help anyone who want to embark into it. Thank you guys.
Okay, so how long have you been in this project? Like how long did it take?
So I think the project took us 2 years.
2 years.
Yeah.
2 years, you're still working on it?
Yeah, we're still improving.
In the Gambia?
Yeah.
What are the challenges that you face like doing the project?
Yeah, of course, like it was very challenging because like you're building something related to agriculture where I have no background in agriculture, meaning I have to understand the domain knowledge. So learning the domain knowledge in agriculture or learning agriculture in general actually gave us a lot of challenges. The other challenge also was like we didn't have like those small pieces where we can able to like how to get integrate together to able to build that physical gadget itself, because it's not only about the software but also it's both the software and the hardware. So ordering those stuffs here in the Gambia, like it's different from the Western country where you just go to the shop and buy those electronic components. But here in the Gambia, we had to order them from China or maybe from America. And normally there's a delay. Sometimes your material will be lost by the way. Yeah, those are the challenges normally we face while building this project.
Okay, ladies and gentlemen, at this point of time, I want to take a pause so we understand one thing. These are people with different foundations coming together for a common goal. Now, when we are building a product, we're always concerned about its durability and maintainability. So that is the biggest question right now. I want them to tell us how durable will this thing last, or how easy is it to be maintained?
So the project, the way it's built, can be maintained even if you have no background in electronics or computing.
So you mean every farmer can use it?
Yeah, every farmer can use it.
Okay.
Yeah, as far as you can text SMS, you can press a button. As far as you can use WhatsApp, you can operate this project. Yeah.
Wow. So do you have something to add on to that?
Yeah, exactly. Because I want to just tell everybody that like this is a new area here in the country. When we talk about like electronics and embedded system, we know that like people are graduating in the university, but the languages that we use normally is either Java or Python. But when you talk about embedded system or embedded C, is talking about like languages that we normally use to program the hardwares. And actually, if we want to change our environment, we must know how to give brains to these hardwares. Ranging from either agriculture to smart doors to smart lights or maybe smart homes. All those things are different gadgets that we need to interact with, and if we cannot interact them with these languages that we used to know. So we must deviate ourselves to learn how to use that language in the embedded system. Actually, that one will give us like another age of learning electronics. So we need to understand about how to apply programming in electronics, and we are about to build an institution where we're going to teach all this stuff so that we will have innovative center where people or maybe students can able to innovate and see it in real time, like see stuffs, our local gadgets, our local doors, our local light bulbs. We are going to program them, not things that we import from China or from America.
Wow, wow, wow. So they got the knowledge, implement it, and they are ready to disseminate. That is the life of a productive person. Now, finally, we're going to ask only one person, like, what word of advice, what word of statements do you have for the public regarding this project?
Yeah, regarding to this project, the advice that we have for the public, yeah, if anyone need it and don't afraid to use it, because one of the challenges that we face in this country, people afraid of trying new things.
Try new things.
Yeah,
exploring.
it's one of the challenges that we face here in this country. So we urge everybody to try this product, and then it works well. It's implemented and then it's working very, very perfect, and it's more than smart irrigation. Yeah, it's not just turning off button, it's whole of automation. Yeah.
Okay, so finally, we're going to ask him to tell us words of collaboration, like the power of collaboration to students that are here or to you that is viewing this right now. Because when we look at this is becoming a success because they collaborated. So can you talk about a little bit about collaboration to someone out there, how it can ease the implementation of goals?
Well, yeah, first thing we are going to we want to create a set of brains normally here in the country. Though if anyone have already got that knowledge, we can able to work with you to solve different problems. But since we don't have this kind of knowledge here in the country, or even if we have, it's very rare, maybe those who learn it outside the country. But here in the Gambia, there's no institution which is teaching in embedded system in electronics. Though we have some institutions that are teaching electronics, but programming hardware in general, there's nothing like that here in the country. So we want to work with people, those who have a background in electronics, to teach them programming in hardware, not programming to build apps or programming to build websites, but programming to give brains to hardware. So we are going to open institution, and I guess our first class might kick off during the summer. And in that case, we are going to do practical based knowledge in such a way that like people will create stuff and you will see not about certification based, but about project based.
So ladies and gentlemen, we have come to the end of the podcast. This is exactly what you needed. If you need more information about this, reference these numbers below so that you can collaborate with them in your future projects. Until later, bye for now.